Hello everyone. In a group of three, Christian, Rohit, and I, Raghav, we have prepared a presentation on man-in-the-middle attacks in a local area network. So before understanding who a man-in-the-middle is, let's understand the three states of data. So data can be at rest, it can be in transit, or it can be in use. So when we say about a data in rest, it is when the data is stored on a device. And when it's in use, it is basically being used by a process. Let's say the data is in the RAM or the registers. And when the data is in transit, it means that it's being communicated between multiple parties. So a person who interjects themselves in between this communication, it's referred to as the man in the middle. And they have full control of the data. They might be passive or they can even be active. By active, I mean that they can even modify the data which Alice wants to send to Bob. And if you remember, then the famous Diffie-Hellman attack, Diffie-Hellman algorithm, that is also vulnerable to this attack. So there are few famous techniques which can be used to perform the man-in-the-middle attacks. So if we talk about DNS cache poisoning, so the attacker here sends a malicious response for the user's DNS query and hence in a way is sending the user to an attacker-controlled machine. The way in which routers work, it's based on ICMP messages. They share where the next hop of information is. So these messages, they are also not authenticated and they can be spoofed by an attacker to lure a user to his own machine. And let's look at ARP cache poisoning in some more detail because that is what we have performed. So first of all, what is ARP? ARP is Address Resolution Protocol. Devices on the internet, they use IP addresses to communicate with each other. But what do devices use on the same network? So they use layer 2 or MAC addresses. So ARP is something which creates a mapping between these IP addresses and the MAC addresses. So since it's critical for the attack, let's look at how ARP actually works. So the machine on the right, 0.2, it wants to send some data to 0.4. So what it does is it broadcasts a message that who has the MAC address of 0.4. So the system which actually has that, it replies that, okay, I am 0.4 and this is my MAC address. And what happens in this case, so the machine 0.4, it also stores the mapping of 0.2 to its corresponding MAC address, which can be used to send the response and any data in the future. And this whole process is super secure. Well, actually, no. So anyone can respond to an ARP request. No one is checking that. And worse, so when 0.4 is maintaining the mapping for 0.2, so that request can itself be spoofed. So the attacker can simply send 0.2's IP address with their own MAC and hence poison 0.4's cache. So whenever 0.4 wants to send anything to 0.2, it would rather get sent to the attacker. Okay, let's now look at attack in action. So what we have here is a group of three systems, A, B, and attack. And A and B would try to communicate with each other, and the attacker would act as a man in the middle. So just to look at some basic configuration. The system's IP address is 2.15, and the other one is 2.5. So if I ping 10.0 to 15, the ping should work. And if I check the ARP cache, so here 2.5 belongs to, so the MAC address corresponding to 2.5 is EDA1. So now as the first step, what I want to do is I want to poison the ARP cache of this system so that the IP address 2.5, it corresponds to the MAC address of the attacker system. So if we quickly look at what the MAC address here is, it's E240. And now I'll run my script to poison the cache on system A. And if I look at the ARP cache now, so 2.5, the MAC address for 2.5 is E240. Now let's look at how we can utilize man in the middle, ARP cache poisoning to perform man in the middle. Let's clear a few things up. And let's make the states of our caches right. Mhm. So right now 2.5 belongs to EDA1, which is correct. Okay. So what I'm going to do is I'm going to open a netcat session on a machine B as a listener, and I'll try to send some data from A to B. So it will be, let's utilize port 500 and again, same thing, 10.0.2.5.5.1. Now, if I send some data, let's say hello, so it just goes to machine B. Okay. So let's first, so once the session is running, now we'll first poison the cache of machine A so that machine B's IP address points to attacker's MAC. To do that, the same thing. And now I'll start a listener on my system, and that listener will be an active listener. So it will snoop on the packets, and it would also try to modify the data which machine A is trying to send to machine B. And so now the machine B should get modified data. Now if I send hello again, so we get XXX, and this is what we get on our listener. So it says that the data which it got from machine A was hello, and it converted it to a bunch of X's. Similarly, if you just send, let's say ABC, then that would also be sent as 3 axes. So this is how we demonstrate an active man-in-the-middle attack between two systems on the LAN. So as a next step, what we are going to do is we are going to completely hijack machine A's communication with the internet. Okay, let's get rid of machine B for now. So the way machine A works, so the way machine A communicates to the internet is through a gateway. Let's look at what the gateway is. So the gateway here is 10.0.2.1. So basically, to hijack that communication channel, what we have to do is we have to point gateway's IP address to the attacker's MAC address. And at the same time, we also have to poison the R cache of the gateway so that machine A's IP address corresponds to attacker's MAC address, so that we can listen to all the requests and responses. So let's look at how a website will get opened on this box first. Mhm. Let's just look at the very first website. So when we are performing man in the middle, we'll again try to capture this data. So let's first poison the cache again. So here we are poisoning the cache of the gateway, and now we'll poison the cache of machine A. And now I'll start my listener, which will just be a passive listener. And before that, what I'm going to do is I'm going to convert my system as a router, so that whatever data it gets for a different system, it will just forward that. But again, since we are a man in the middle, we get hold of all the data which is passing between the channels. Okay. Now I'll start my listener here. If again I try to load my website, then wow, I have access to all the data, all the communication which was there. So if we look at, we get some HTTP data here, and yep, this is all the requests and responses which went from machine A to the internet. So this is what a basic man in the middle attack looks like. Now, if we talk about the lessons which we learn from such a scenario, is that security is generally built on top of a protocol and it's not rather bolted into it. And similar is the case with other protocols like IPv4, which have a lot of security loopholes. And because of this, R has absolutely no security measures at all, which causes a lot of problems. So to defend against such attacks, so the best way is to secure the channel where the data is in transit. So the way to do that is create an encrypted tunnel between the sender and the receiver so that the data which is there on the channel in transit, it's gibberish to the attacker. So similar is the reason why we use HTTPS and not HTTP, because HTTPS creates a TLS tunnel over which the HTTP data is sent. Well, if there are any questions, then we would be more than happy to take them at either of these email addresses. Thank you.